and thanks everyone for joining today. So here on the screen, we have an agenda outline of this presentation. We'll start with the introduction to energy efficiency, discuss some of the benefits of energy efficiency projects, discuss energy auditing and how that can lead to implementation of future energy efficiency measures. We'll go through some typical project types and discuss financial resources for helping to fund energy efficiency projects. So we would like to begin with a poll to our audience here and just ask and survey which topic are you most interested in learning about today. So in a moment, you'll see the poll come up on the screen. Thanks so much, Chris. And if you wouldn't mind just submitting your answer there so we can get a sense of where your interests are in attending this webinar today. So it appears that people are interested in hearing about some of the benefits of energy efficiency, learning a little bit more about energy audits and the financial resources, which I would estimate are of interest to many of you. So thank you so much for responding to that. So with that, we can jump into an introduction to energy efficiency, and I'll start us off here. So energy efficiency can be defined as using less energy to achieve the same output or service, resulting in less emissions. So we want to note that when we say energy efficiency, it can apply to any building type. So residential, commercial, industrial, municipal buildings. And it also applies to any form of energy consumption. So electricity is one that we're, all familiar with, but similarly, gas, oil, propane, or other energy sources can all be under the main energy efficiency umbrella. A fun fact that we found here is that the world energy system is only about 40% efficient, where 60% of energy inputs is wasted. And what that tells us is that there is a lot of room for improvement because having over half of the energy inputs for building wasted is not a good stat, not a good fact. So total carbon emissions, we have a pie chart here of various building types that exist out in the world, along with their carbon emissions. And so I was actually surprised by this one that warehousing represents a large portion of carbon emissions. And I'm wondering, I want to check this data point if that includes data centers as well, because that isn't called out, but that's a hot topic nowadays in regard to energy and water use. So I'll continue. With that very brief introduction, we wanted to also survey the audience and see how supportive your leadership may be of energy efficiency efforts. Curious as to maybe that's why some of you are attending today, to learn more about energy efficiency and be able to bring some of these facts and benefits back to your leadership to help get projects that you may be interested in supported and or funded. So again, if you would all be so kind to respond to our audience poll here on the screen, just so we can get a sense of this. All right, and we're seeing responses come through that indicate that your respective leaderships are somewhat supportive to very supportive. Okay, so that's great to know, and hopefully you'll be able to take away some facts from this webinar that can be used as discussion points for your various teams and leadership to help you accomplish even more that you may be interested in accomplishing. All right, so moving on, I'm going to pass it over to Sam to talk about some of the benefits of energy efficiency projects. Okay, thank you, Robert. We saw your response as well. Noted. Thank you so much. All right, Sam, I'll let you take it from here.
All right, thanks, Joanna. So I'll talk about cost savings, one of the important benefits that we can get from energy efficiency. So byproduct of energy efficiency or implementing energy efficient practices is reducing your monthly energy bills, whether that's electricity, natural gas, even water, making energy use more affordable for us all. Often there is a higher upfront cost, at least when we compare energy efficient practices to standard best practices. But cost savings do develop over time and lead to, more efficient use of your energy over time. So some utilities, some of the call-in members are from Massachusetts and New York. Some utilities in those states provide rebates and discounts to offset upfront cost on customers. And that enables, us to implement some of these energy efficient practices. So the cost of doing nothing, on over here on the left, this image where, our electric bill, let's say, is $250 a month. So over a 2-year period of time, we're going to have to pay a utility bill for $6,000 total to the utility costs for doing nothing. And then by taking an action, by making our system or our building more efficient, they could potentially become 30% cheaper or more efficient due to energy efficiency measures or practices or projects. So as a result, our scenario B is saving energy and using $175 per month. So as you can see, over a 2-year period, that's $4,200 in utility costs, which is a dramatic reduction to just doing nothing. So as a result, it is something that can help your financials down the road. Next slide. So environmental benefits. So some of the additional benefits, and sometimes even more focused than just the cost effective or the cost efficient benefits of energy efficiency, is helping to reduce environmental impacts of what we do on a daily basis. So energy efficiency projects can reduce your carbon footprint from doing things like lighting up your building or lighting up a space or just, heating things to comfortable temperatures. All that uses energy and actually increases, how much carbon emissions we produce as a consumer, as a homeowner, building owner, occupant, resident. And to society, this actually increases certain things, like our carbon footprint leads to air pollution. It could lead to water pollution, things like that. So by implementing energy efficient practices, this could reduce the amount of electricity generation that's needed at a power plant. So that could reduce emissions. So that can support clean energy and reduce smog in certain areas. Less land use, in terms of how much power and electricity is being generated. It uses land to do that because, we might be implementing um, a new expansion of a power plant or an expansion of a transmission line or something like that. So by reducing the amount of impacts there, we can support biodiversity and protect our ecosystems because of the lesser land use. And then on the water side, water is being used at power plants and for electricity generation for cooling the power plant and to run turbines and things like that. So we can reduce the heat pollution, right, which would be basically the heat that's going into our water bodies, our water systems in lakes and rivers as a result of using energy locally. So by doing all this, we can conserve natural resources. Next slide. There's also operational improvements, right? So at an industrial manufacturing facility or at a school or at a building that, we have occupants there that, do things that, need to have, focused on like some minute detail. There's operations that are involved with those activities. So energy efficiency allows, this first line says, allows for equipment to operate more optimally. the well-oiled machine, we like to call it. So by allowing equipment to run more optimally, right? So that could be your heating and cooling system. There could be less squeaky devices, right? In like a fan system, there could be things that allow somebody on a process line to do their job more effectively. So those types of things will increase operationally, what's going on in a building by doing energy efficient things. And additionally, it can help expand or increase an equipment's operational lifetime or lifespan and reduce the maintenance required. So, in the example where you have a older filter or a older motor, that could lead to uh, you know, increased energy usage from, less efficient equipment. Basically, that can also reduce the amount of maintenance they need to put on the equipment as well. So it's more in lines for a preventative maintenance type of implementation. And additionally, increasing light and air quality. So light, we're talking about, the light that goes into the space. So by improving the lights or by upgrading your lights to be more energy efficient, putting in light emitting diodes, LEDs, that can additionally increase the amount of or improve the light quality in the space, allowing for operational improvements. And then same thing with air quality, right? If you're updating or improving things related to a ventilation system, you can increase the air quality in that space. All right, next slide. And I think this is the last benefit one, but not the least important. There's also utility benefits associated with energy efficiency projects. So by lowering the cost of utilities, obviously that's a direct consumer benefit, but that's also a benefit to the utilities too. You're increasing customer satisfaction. We're reducing the electricity peak demand or even the natural gas, peak demand needs for distribution. And that will lower the amount of utility construction projects that need to be done, lowering costs to the consumer and lowering the needs for, new power plants, new transmission lines. Next slide. And I'll hand it back to Joanna for energy auditing.
Thanks, Sam. So next we're going to talk about one of the precursors to implementing energy efficiency measures, which is conducting an energy audit. So as we like to say, you can't reduce what you don't first measure. So the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRAE, has a standard for conducting energy audits. There's 3 levels of energy audits that fall under the ASHRAE standards, level 1, 2, and 3, as described here. There's also you can also conduct a pre-level 1 audit, which we would call a benchmark or energy use analysis. So that's really the highest level, the least detailed, but this is a way to get your total building energy use accumulated and measured and calculated. There's a tool that's available by the US EPA called Energy Star Portfolio Manager. This is also a high level tool that can be used to compare your building's energy usage to similar buildings. Data is imported by building category, so you can just get a baseline sense of how your energy use compares to similar buildings. Moving up the scale here, a level 1 energy audit is the more simplified audit compared to levels 2 and 3. This would include a walkthrough assessment of a building or facility where a qualified professional would identify the high-level potential for energy savings measures. So that would be based on a visual observation. A level 1 energy audit would include the qualitative assessment of energy efficiency measures, maybe some high-level calculations on cost savings as well. Moving up to a level 2 energy audit, this would also include a facility walkthrough where a qualified professional would observe all of the energy consuming areas of a building, equipment, and devices. This includes a quantitative assessment of energy efficiency measures. So the estimated savings would be calculated as part of a level 2 audit, as well as a more detailed summary of what the implementation may look like in terms of cost to implement the measures and a calculation on expected savings. The highest level of audit, level 3, is also known as an investment grade audit. So this would not only include a walkthrough and observations by a qualified professional, but it may also include metering actual equipment and gathering data for a number of weeks, up to a month, to get a really solid sense of how much energy is being consumed by particular equipment or devices. And then this would include the most detailed estimate of both energy savings, cost estimates for implementing measures, and expected cost savings. So depending on your needs, or where you are in your energy savings journey, one or more of these may be appropriate to have conducted at your facility to help inform future projects. So talking about energy efficiency measures, they fall into different categories as well. The first one here is a no-cost measure, of which there actually are many, believe it or not. Every energy efficiency measure doesn't need to cost money. A no-cost measure is just that, a project that reduces energy with no significant associated cost. Examples of this can include operational measures, where maybe changing the time you use certain equipment in your building or facility would allow it to be operated during an off-peak time, so that there is no impact to your operations or production or whatever you may be doing, but simply changing the time that you operate equipment can save you money on your electricity bill, if, like I said, if you fall into an off-peak time. Another example of a no-cost measure is energy efficient power strips that are often free or provided by some utility companies at no cost. So using the energy efficient power strips, automatically shutting devices off when they're not in use can conserve energy, and that can be a no-cost measure that could save you on your electricity use and cost. So moving up to the low-cost measures, it's projects that reduce energy with relative small associated cost. We would put lighting in this category, upgrading to LED lighting, maybe replacing some small motors with more efficient motors. Those can be example of relatively low-cost measures, changing out equipment or devices for more efficient devices that do have a cost associated with it, but should pay back over time through reduced energy usage. And then finally, moving up to capital intensive measures. Certainly an energy audit could help identify these intensive measures that would, with the intention of significantly reducing energy consumption and costs, but also require larger capital investment. So examples of this could be wastewater treatment plant process improvements, blower upgrades, and items that do cost a lot, but also hopefully save you a lot in energy use and costs at once they're completed. Discussing energy audits, I mentioned that qualified professionals would often go in and conduct the audit. So some of the certifications that can apply to those who frequently conduct energy audits include Certified Energy Manager, Certified Energy Auditor. Those are both certifications that are standardized by the Association of Energy Engineers. Engineers are also capable of conducting energy audits, so engineer in training, engineer and intern, depending on the state that you're in, and certainly professional engineers. Lead Green Associates and ResNet HERS certified professionals are other examples of certifications that people can earn and achieve that would allow them to conduct energy audits in a qualified way. And then we also have a list of some of the skills that these professionals would have and that are all necessary in conducting and producing a complete energy audit report. So project management skills, data modeling skills, grant funding and knowledge is very helpful. Being able to communicate well, be diligent, any engineering and analysis skills, as well as GIS mapping are all important skills that professionals have that conduct this line of work. And next, I will pass it back to Sam to discuss some project types relevant to energy efficiency. Sam?
Sure. So for project types, HVAC, which is heating, ventilation, and cooling. So our heating and ventilation cooling systems can be more efficient, but they do provide a large portion of our energy usage in commercial, in a lot of industrial buildings, municipal buildings as well. So increasing energy efficiency, as we spoke before, can lead to more reliable operation, increase indoor air quality, potentially extend equipment lifespan. So those are some important benefits of doing efficient things related to our HVAC systems. So on the heating and cooling sides, typically this means implementing more efficient systems when we upgrade our systems. So this may be something that can be considered as buildings expand, or as you move into a new facility, or as you operate or change operations in a facility, looking into equipment that can or needs to be upgraded, for maintenance reasons, but look at it to see how can we be more efficient? How can we save energy, save costs, and save environmental emissions here? So those are some of the heating and cooling ways that you can upgrade. Additionally, on the ventilation side, there's ways to implement heat recovery or energy recovery practices. So those are measures that can be done there. On the ventilation side, you can also do demand controlled ventilation. So let's say you have a building with a very, high bay community room, or a gymnasium, or a auditorium, or some sort of space that's, a high bay space that needs a lot of fresh air in that space. But by implementing certain controls there, there might be, occupants not in that space all the time, right? 24/7. So there might be certain times where you can ventilate less that space, and therefore reducing some of those ventilation loads will also reduce your heating costs as well there. So that's kind of more on the equipment side, and then back to the controls. You can get into something called building management systems, which we'll talk about later. Next slide. So lighting. So lighting is, our light fixtures, our light bulbs that are in our buildings, in our residences, and how can we make those more efficient? So it could be, and typically this is one of the more cost-effective ways or cost-efficient ways to implement energy efficiency projects. And that's typically because, a lot of older buildings, a lot of municipal buildings, they'll have older, light fixtures in certain locations. Maybe not every room, but if you've been upgrading over time or replacing light bulbs, you might be, moving towards high efficient devices, but LEDs are, likely the most efficient equipment type that you can implement nowadays. In addition, there's controls features. So dimmers and motion switches, basically what that allows you to do is sense, when the full 100% lighting is not needed. So if a area is next to a window or a skylight where you're getting a lot of ambient light coming in, and you can reduce that energy usage or the light output from those artificial lights, to help save energy when, there's sufficient ambient light available. And then similarly, the dimmers allow for kind of a more robust way to operate the individual light fixtures. And that can be also controlled through motion sensors. And motion sensors or occupancy sensors can basically determine, when occupants are there. So instead of having things on a certain schedule, to catch the times when people aren't, maybe in a space for certain breaks or certain off times. Motion sensors can allow for that energy to be reduced during off periods when it's not needed. Next slide. All right, so building envelope. So this is a fun one. So the picture over here on the left is an image of a infrared view of a building, right? So looking at this particular building, you can see the red areas are the warmer areas and the blue areas are the colder areas. So what this infrared camera picture is showing us is that there's leaks or there's drafts near the windows, right? Near crevices in the roof line, compared to the wall. So you can see that there's, sufficient energy inefficiency in this building. And to reduce the thermal energy loss from poorly sealed buildings, we can do certain things to make that more efficient. We can put in better insulation into the walls, attics, roofs. We can address drafty windows through either interior storms or adding caulk, putting in weather stripping along exterior doors. Exterior doors, a lot of them, may have had weather stripping or door sweeps, and a lot of them can degrade over time through use. So it's good to kind of keep up on that and make sure that you can kind of, when you're inside a building looking out, that you're not seeing the light of day where you're not supposed to. Next slide. So motors and pumps. So motors and pumps are a significant energy usage or energy source at buildings like pump stations, treatment facilities, even offices use, pumps and motors for ventilation or circulating hot water, cold water ventilation. But specifically in treatment facilities, electric motors consume a portion of the energy usage there, and also in industrial as well. So on a global basis, 40% of the global electricity uses is from electric motors. There are small efficiency gains that can be done from just replacing an older motor with a newer motor, upgrading the efficiency on it. Small efficiency gains that can be done through those replacements lead to long-term energy and cost savings. There's also more minute strategies to improve pump and motor efficiency through controls, right? So controls where you're not operating your motor, you're not operating your pump as much as the capacity of the system could dictate. So without a particular control like a variable speed drive or a variable frequency drive, we might be running this equipment at 100% all the time, even if we don't need it. So by running those more efficiently, by controlling them more efficiently, and by making upgrades where we can, over time, our energy usage can dramatically decrease. Next slide. In building controls. So building controls is primarily related to our HVAC systems, but can also be connected to other types of end uses and systems. So an EMS or BMS system is also called an energy management system or building management system. So these types of control devices control and monitor the different energy systems in each space. And this is the different zones for your heating and cooling systems. This allows the heating system to communicate with the chiller system and other cooling systems and ventilation. So you're kind of controlling them all together so you can implement, at minimum, scheduling the system so that they only run when needed. At most, you're implementing more efficient practices like outside air resets, sensing temperatures outside, sensing humidity in the space, looking into the lighting, what's being done there. And sometimes if you're in a building that, like a hotel or some sort of building where you have people going in and out a lot, there's operating or occupancy controls that can be in each space to define, whether or not a space is occupied. And once the control determines if a space is occupied or not, it will in turn communicate with the control system, communicate with the heating, cooling, and even lighting systems to turn off when not needed. So some of that centralized building management system control can lead toward a more robust and more efficient practice there. And basically, the DOE has done some studies, and successful implementation of high performance building control systems has been shown to reduce HVAC energy usage by as much as 30%. Retrocommissioning. So retrocommissioning is a type of practice that we're talking about looking at an older building. And the building might not be 100 years old. It might have been constructed 10 years ago, for example. So an older, inefficient building, so where even with a new construction building that might have been value engineered, or certain components of which, were downgraded during construction, due to increases in costs, for example. So we're talking about an older building or an inefficient building that is running, as is, but basically we're providing it the necessary upgrades to increase energy efficiency. The way we do that is through looking at the building management system, looking at sensors in a space, making sure that the control system is communicating properly with the equipment, making sure that the fans are running in the right direction, not the, reverse direction, making sure that electrical wires are connected properly. So that's all part of retrocommissioning. We can also look at the building envelope, as a retrocommissioning type of measure, and we can see, insulation that's been degraded or removed over time from a contractor that came in and did some upgrade in your attic. There might have been some insulation that was there that might have been, stacked onto something else. And so by retrocommissioning, we're talking about just, making sure that the building is going back to the way it was designed for. There are a lot of situations where buildings are, that were designed and constructed, 30 or more years ago, are now being used for something else completely. There are, converted buildings into multifamily facilities. There's a lot of different types of situations where the operations of a room or a zone or an entire building might have changed. And sometimes the equipment that's serving the space, or the controls that are serving the space, specifically, thermostats, things like that, they might not be designed, or they might not be set to what the new operation is. So retrocommissioning allows for us to make sure that's reset and goes back to being more as to what is being recommended or designed for, and is more efficient. Industrial processes. So industrial processes, we're talking about manufacturing facilities. We're talking about data centers. We're talking about wastewater, water treatment facilities in towns and cities. So these types of facilities have very specific equipment that allows for processes to be done. And the purpose of those systems is to, make a critical infrastructure thing happen. So, for example, the treatment of water, or moving water around, in different ways. It could be manufacturing, creating new widgets or new, plastic devices, manufacturing anything really. So that all uses energy, and all those systems that manufacture can be run efficiently, but they can also be supported through energy efficiency. So by doing, an energy audit, by looking at an energy assessment, or looking at the individual measure types that are in a facility, the individual equipment, we can figure out what's currently in a building, and then how it can be upgraded or how it can be run more efficiently. So some of those examples in an industrial process type of facility are variable frequency drives. So that can allow for the speed of the motor to be adjusted to be more efficient. Compressed air. So in a compressed air system, that, let's say you're powering equipment or you're moving some device up and down, or you need just compressed air to fill tires, let's say. That's another application for compressed air. Compressed air is very inefficient. There's ways to look at, more efficient compressors, more on the distribution side, looking at how to identify and repair leaks that are in the system. And those all add up. So all those things related to the compressed air system can be done more effectively. And then heat recovery. So heat recovery can be used to capture heat that's basically leaving our building. That's, it's waste. It's going out of the stack. Or potentially inadvertently out of windows and walls through lack of insulation or, sealed windows. So there's systems that that are designed and engineered to capture that heat and use it either as an industrial preheat device to preheat an area where you might use for process heating, or you can use that heat to space heat a building, right? Let's say there's one particular area that has lots of processes going on where you have a lot of motors running nonstop. Instead of ventilating the air, instead of having the air just literally go out the window, the air can be used, to heat up an office space, for example, and reduce the energy in that space. So that's waste heat recovery in a nutshell.
All right, I'll take it back from Sam. We have our final audience poll here, and the question we would like to ask you all is, what are the biggest barriers you face in implementing energy efficiency projects? And when this poll comes up, it's going to be an open-ended response, so you can type anything that you like here in the response bar at the bottom. And as you're all entering your responses here, I will say this is open-ended. You can say anything you want. However, we had a suspicion of what many of the responses would be. And our suspicion is that many of the barriers would be related to money and cost and financing. And that is definitely what we're seeing in terms of responses here. So as suspected, time, money, and cost. So moving to the next section of our presentation, budget restraints, I see that. So related to money and cost, we're going to conclude our presentation with a discussion on financial resources to help you implement, finance, and fund energy efficiency projects. So beginning with utility rebates. So I know many of us here in this call are in different geographic areas. We have different utility companies that serve our buildings. However, there are many utility rebate programs out there despite no matter which utility service territory you're in. The programs may look a little different, the details and cost funding amounts may be a little different, but most utility companies do offer rebates to help fund and offset the cost of energy efficiency projects. So I will share a source of this information. It's actually at the bottom of the slide in the corner. It says DSIRE, and that is a website that you can go to. It's updated on a regular basis by a university in South Carolina, I believe. I think we'll show another slide where you can a snippet from the website. You can select your state and then drill down into the various utility programs that are applicable to your location. But this desired DSIRE website does share overall over 1,118 rebate programs in the US that can help fund energy efficiency programs. So in addition to utility funding, which I encourage you all to go to that website and check out, there are municipal grants that can help fund energy efficiency projects. So these grants are designed to help municipalities reduce energy costs and increase efficiency. Some examples of organizations and programs are here on the screen. Some of you may be familiar with the Mass Clean Energy Center, the Green Communities program in Massachusetts is run by the Department of Energy Resources. But no matter which state you're in, you could also search on this Desire website for municipal grant programs. This is a map of the US here. Again, when you go to the website, you can click on your particular state. And as you can see, most states have some sort of energy efficiency grant programs available. Again, the details will vary, but here in the Northeast, at least New York and the Northeast, there are often programs that prove to be quite beneficial. So I encourage you again to go and check out this website. At the federal level, there are tax credits and deductions that certain project types or customer types may be eligible for. Some examples are listed here. So there are tax credits available for solar installations, heat pumps, biomass stoves, building envelope improvements, EV charging stations, and even to conduct home energy audits. So we want to encourage all of you again to see what may be available to you depending on the project type and that you're looking to implement and the customer type that you are. As a point of reference, the investment tax credit, which is still active right now, however, going to be going away this summer, can provide up to 40% of the project cost back as a tax credit. Customers receive a check directly from the IRS once the project is completed and the proper documentation sent in. So that's huge, 40% of a project cost being given back to the customer in the form of a tax credit can help turn a project into a favorable financial sell to your leadership as compared to something that wouldn't be eligible for a tax credit. So just know that the message overall is, local utility funding, state funding, and or federal tax credits all may be available to help fund a project. And oftentimes all of those can be combined together. So you are eligible and able to use all three sources of funding together, take advantage of the utility rebate and any state grant funding and any tax credits that may be eligible, and combine them all to turn your project into a hopefully fundable and successful project. And then finally, financing is available if, there just isn't enough funding to cover a project with your own capital resources. There are a number of financing options available. We discussed a few of them here. The PACE program, that acronym stands for Property Assessed Clean Energy Financing. This is a tax assessment where the tax assessment is applied to the property itself and not necessarily to the owner. So if you obtain PACE financing and then you sell your property, the future owner can take over the payments of that. So some people have found that to be beneficial as a way to fund a clean energy or energy efficiency project. NEF, the National Energy Improvement Fund, is also a utility approved third-party financing company that specifically is dedicated to help funding energy efficiency and clean energy projects. And then the final one listed here, on bill utility financing, is offered by utility companies. The financing rates vary. They've gone as low as 0% at times to I don't know what the max would be, but they vary in terms of their rates, where you implement an energy efficiency project, the utility helps fund it, and then they let you pay back the cost of that project over time directly on your utility bill. So those are just some options that may be available to also help fund energy efficiency projects. And again, financing can also be combined with the previous funding sources mentioned, so you can take advantage of all of them together as possible to help you implement a project. So with that, we are at the end of our presentation. Sam and I did want to include our email contacts here in case you have any further questions or wanted to reach out to us. So feel free to jot down our emails. And as Chuck said, this presentation was also recorded, so please refer back to it at any time if you found any of this helpful.